Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1997. This question is a number theory exercise, and we have a, b, c are positive integers, and we know that a is less than 2b. The question says if we divide a to b, the remainder will be 2r. And if we divide a to c, the remainder is r. And if we divide b to c, the remainder is also r. The question asks us to show that a plus b divided by 2 is divisible by c. First round of Iran Mathematical Olympiad is usually consists of multiple choice questions. You get 30 questions for 3 hours, 6 minutes per question on average. So maybe I spend 5 to 10 minutes try to solve this exercise and then come back and see the solution. So these are the options that we have. A is a plus b, b is a plus b divided by 2, c is a plus b divided by 3, and d and e we have it here. All right, let us look at the exercise. The exercise says that if we divide a to b, the remainder is 2r. In this case, I wrote it a modulo b is equal to r, but we can write it also in this format. A is equal to b times k plus 2r. And we know that this remainder has to be larger or equal than 0 and less than this b. Okay, so we have this information. But the exercise also tells us that a is less than 2b. So if a is less than 2b, that means k has to be either 0 or k has to be 1. Because if k is 2, then a will be 2b plus 2r, and this statement would not be correct. Therefore, k has to be either 0 or 1. Okay, so if it is 0, a will be 2r. If it is 1, a will be b plus 2r. Let's take this case, a is equal to r, and we see what we obtain. Obviously, we also know from the properties that is given in the exercise, a modulo c is equal to r, or basically, if we divide a to c, the remainder is r, so a can be written as c times w plus r, and r is equal or larger than 0, less than c. And now in this case, we know that a is equal to r. This is one scenario. So 2r will be equal to c w plus r with r disappears, so we know that r is equal to c times w. But we know r is less than c. Therefore, w has to be 0 basically, and r becomes 0. So if r is 0, then it means a is 0. But this is contradiction because the exercise says that a, b, c are elements of positive integers. So they have to be larger than 0. Therefore, we conclude that a cannot be equal to 2r. A has to be b plus 2r. All right. If a is equal to b plus 2r, we know that r becomes a minus b divided by 2. Just move the b to the other side and divide by 2. But also we know that the remainder of a to c is equal to r, so a is c w plus r. And in this case, instead of r, I can put this value. So a becomes c times w plus a minus b divided by 2, and we take this one to the other side. A divided by 2 simplifies, this becomes plus, so a plus b divided by 2 is equal to c times w. Therefore, we know that c divides a plus b divided by 2. All right, so in this case, obviously, this option disappears. We know that this is true, but we don't know whether this is the smallest one or not, because the question asks us what is the smallest number among the following options. So we know that this is correct, so therefore these other options cannot be correct. But now we have to also show that either maybe this is always correct or maybe this one is not correct. Let's see what we can do. All right, we said that a has to be equal to b plus 2r, and based on this property given, if we divide a to c, we know the remainder is r. If we divide b to c, the remainder is also r. All right, what we can do is that we know that c w plus r is a, and this one is also a. So instead of b, I can replace its equivalent, and basically we get to this equation. So in that case, this r with r disappears. This one goes to the other side. C times w minus v is equal to 2r. But from this division, we know that r has to be less than c. Because we know that r is less than c, therefore we have only a limited options for this equation. For example, w can be equal to v. In that case, R becomes 0 and everything works properly. So if W is equal to V, yeah, R becomes 0. In this case, A becomes equal to B because this is 0, A is equal to B. And in this case, actually, we can give an example because everything fulfills the properties that's given in the exercise. So A is less than 2B because they are equal. So A for sure is less than 2B. A modulus B is equal to 0 because they are equal. A modulus C has to also be 0. So if we give an example for A, for example, I gave A and B equal to 10, then C has to divide the A and B. So basically it means C, for example, I take it 5. And then we know that A modulo B is 0, 10 modulo 10 is 0, 10 modulo 5 is 0, 10 modulo 5 is 0. So we fulfill all the properties that is given in the exercise, but if we calculate A plus B divided by 3, we cannot actually divide 10 plus 10 to 3. It would not be an integer. Therefore, this number is not even an integer. So basically, in the exercise that we have, the option A plus B divided by 3 is not always an integer, and therefore it cannot be a correct answer. The other solution for this equation, for example, it can be W should be equal to V plus 1, so totally this is 1, and C equal to 2R. But actually, as I said, we don't care about these cases because we already found a counterexample that eliminates the last option. Therefore, we know that option C is wrong, and option B obviously is the correct answer. Let's see what we have learned throughout this exercise. When a number is divided by another number, it can be always written as divisor multiplied by an integer plus a remainder that is equal or larger than 0 and smaller than the divisor. So A can be written as C times W plus R, and R is equal or larger than 0, less than C. The second point is to manipulate the equations to obtain relationship between the remainder, the divisor, and the number itself. It's always useful to write this equation and basically play with them and try to gain additional information. All right, so that's the end of the video. I hope that you learned something new. See you next time. Bye.